Let's look at some rational applications. There are two main types we're going to look at in this video. There's what we call work rate problems. This is when you have two people that are working together, but they work at different rates, and you're trying to figure out how long it takes them to do a job together. So let's take a look at two examples of work rate problems. Example 1 says Sarah can clean the garage in 3 hours, but it takes Angie 4 hours to do the same job. How long would it take them to clean the garage if they work together? So Sarah can clean the garage in 3 hours, means she can do the one job in 3 hours. It takes Angie 4 hours to do the same job. So the same job in 4 hours would be 1/4 for Angie. And then we're trying to figure out how long it takes them to work together. So one job working together, and X would be the amount of time they take to work together, which is what we are looking for. So that is our variable. We could get a common denominator so that we can add them up by hand, or we could just use the calculator. So I'm going to multiply the first fraction by 4 on the top and the bottom, and the second fraction by 3 on the top and the bottom. So that way I have a common denominator of 12. So 4/12 plus 3/12 would equal 1/x. And I'm just going to continue over here where I have more space. So that gives me 7/12 equals 1/x. This is just a basic rational equation. So I'm going to cross multiply, and I get 12 equals 7x. And then divide both sides by 7, and I get 1.7 equals x. If I just divide 12 divided by 7 in my calculator, it's about 1.7. Now 0.7 does not really tell me how many hours or minutes, so you could say 0.7. Let me type it in another box. Let's see, 0.7 times 60 would help me put this in terms of hours and minutes. So it would be 1 hour and 42 minutes, which might be a better looking answer for the problem instead of 1.7. Let's look at another one. Ethan takes 15 minutes and Jake takes 60 minutes for the newspaper distribution in Mooresville. How long would it take for both of them working together to distribute the newspaper? So Ethan does one job in 15 minutes. So we put 1/15. Jake does the same job, so one job in 60 minutes. And then we're trying to figure out how long it takes them to work together, so we set that equal to 1/x. And then I just need to get a common denominator so I can add them together. So I'm going to multiply this first fraction by 4. And that'll give me 4/60 plus 1/60 equals 1/x. And again, I'm just going to scoot over here where I have more space. So that gives me 5/60 equals 1/x. So then I would cross multiply, and I get 5x equals 60. If I divide by 5, I get x equals 12. So they would take 12 minutes working together. All right, so that's two work rate problems. Let's look at another type of rational application. I call this the real-world application of asymptotes. Rational functions are actually in our everyday life more than we might think. So this example might help you think of a scenario where you've seen them, but you didn't know that's what they were. If you were at an ice cream shop and they are running a weekly special that, let's say you buy one cone for $5 and then additional cones are only $2.50 each, so they're half price. As you buy more and more cones, you have more lucky friends. What is the average cost per cone? And so we set up this function of $2.50 per cone after the $5 cone divided by the total number of cones that were $2.50. If you graph this function on a graphing calculator, it is interesting to note that you have a horizontal asymptote. So that's y equals 2.5, and that would represent the cost that each cone, like the average cost is approaching $2.50. So average cost per cone approaches $2.50 because you divide the cost of that initial cone with each person that buys another cone. So like the $5 gets broken up. The more people that buy a cone, the more of that gets distributed among those people, so your average cost per cone would approach the cheaper amount, which is $2.50. So let's look at two more examples. Number 3 says, similar to the ice cream example above, how might the same process apply to movie tickets, where the first ticket is $12 and each additional ticket is $9. So it would be, I'm going to use T instead of X. So $9 per ticket plus the original ticket was $12. So average cost per ticket would be $9 per ticket plus 12 divided by the number of tickets at $9. So does this graph also have an asymptote, and what does it represent? So I can look at it and tell what it's going to be, but let's just type it in so you can see what happens again. So 9x, we didn't type the other one in, so let's type this one in. 9x plus 12 divided by x. And then if we look at the graph, I'm going to hit the home button. You see that it's a rational function. The reason we don't need the negative part of the graph is because we're talking about something that wouldn't make sense as a negative number because they are number of movie tickets. But if we look over here on the positive part of our graph, we can see that it's approaching $9. See how it keeps staying right at 9? And so our asymptote would be at y equals 9, and that represents that the cost per ticket approaches $9. Because like I say, the $12 you spend initially gets broken up into all the people you have purchasing a ticket, so eventually it just becomes a very small amount. So your average cost per ticket would approach $9, that lesser amount. Number 4 says, suppose the average cost per person, A of X, to attend a school's sports banquet is approximated by A of X equals 7X plus 250, all divided by X, where X is the number of people who attend. How many people must attend to bring the cost to $32 per person? So they've said the average cost per person, A of X. So that's where we're going to plug in the 32. So put 32 equals 7X plus 250, all divided by X. Then we just need to divide by X to figure out how many people need to attend, because X is the number of people who attend. So the first step I would do is multiply both sides by X to get it out from the denominator. So we bring down 7x plus 250 equals 32x. Then let's subtract 7x. So we get 25x equals 250. And then we can divide. I just got ahead of myself. So if we divide by 25, we end up with x equals 10. So 10 people would need to attend for the cost to be $32 per person. So those are just a few examples of how we can use rationals to apply to our everyday life.